Question 17. The journey has two parts, a train ride and a bus ride. The probability of the train being on time is 0.75. The probability of only one of the two parts being on time is 0.48. If the probability of the train being on time is 0.75, the probability of it being late is 0.25. Okay. Now the probability of only one of the two parts being on time is 0.48. So if you think about this in terms of different paths or options, so we're going to do a probability tree. So if you think about it about being the train ride and then the bus ride, and the train ride or the bus ride can be on time or not on time, not, on time, not. Okay. So the probability of the train being on time was 0.75. Now, I don't like to use decimals on probability trees, so I'm going to change that to 3/4. Probability of the train being late, therefore, is 1/4. The probability of only one of the two parts being on time is 0.48. Now, there are multiple combinations that we can have. We can have both being on time. Let's go here. We can have only the train being on time here, only the bus being on time here, and none being on time here. So what we're really interested in is these two parts. These two parts show only one of the two being on time. So whatever these probabilities are, they should add together to make 0.48, which I'm going to write as 48 over 100. Alright. The two events are independent, which means that their probabilities add up to make 1. And it doesn't matter, well, sorry, no, it means that the probability of the bus being on time or late doesn't depend on whether the train was on time or late. So if we think about this in terms of A and B as probabilities, this would also be A, and this would also be B. Alright, so we have pretty much everything we need now to answer this question, although it looks fairly complicated at the moment. We have the train being on time, probability is 3/4. The probability of the bus being late is then B, so if I multiply that by B, and then I add 1/4 is the probability of the train being late, but the probability of the bus being on time is A. That right there represents these two probabilities added together. 3/4 times B is this one, and 1/4 times A is this one. So they should add up together to make 48 over 100. So 3/4 B plus 1/4 A is 48 over 100. Now, I said earlier that the events are independent. Sorry, yes, I did say that. But also I know that these two are going to add up to 1. The probability of the bus being on time or late, those are the only two options for the bus, so they should add up to 1. So A plus B equals 1. I can rearrange that to get B equals 1 subtract A. And I can substitute that into here. A really clever thing to do. So I have 3/4 of 1 subtract A equals 1/4, sorry, not equals, plus 1/4 A equals 48 over 100. Now if I expand the brackets, I've got 3/4, take away 3/4 A, plus 1/4 of A equals 48 over 100. 1/4 A take away 3/4 A is negative 1/2 A. At this point, I know I don't usually like working with decimals when it comes to the tree diagrams, because it's easier to multiply the fractions when you use fractions instead of. It's easier to multiply when you use fractions instead of decimals. However, in this case, this can probably be written as decimal, so I'm going to write at the top left over here. I'm going to carry on, okay? So I'm going to change it back to decimals. I'm going to go 0.75, take away 0.75a plus 0.25a, so we're left with take away 0.5a equals 0.48. We can solve this as an equation. We can add half a, 0.75 equals 0.48, add 0.5a. We can take 0.48 away from both sides of our equation, which leaves us with 0.25, hold on, that's 0.2 less than half, so 0.27 is 0.5a, times those by 2, then I've got 0.54 equals a. So the probability of the bus being on time, which was a, is equal to 0.54. Now that's quite tricky, obviously, but you get 1 mark for getting a correct link between 3/4 B and 1/4, add 1/4 A being 0.48 or 48 over 100. You get 1 mark for forming a correct equation in terms of just A or just B. So recognizing that because they add up to 1, you can do this kind of thing. So using that to get something like up here, that's the second mark. Then rearranging and solving is a third mark, and if you got it all correct, it's your fourth mark.